Welcome to the exciting world of Internet of Things IoT. In this short tutorial, we are going to see about the basic building blocks of IoT. But before we jump into IoT, let's take a look at a couple of inventions that had a huge impact in this world. 1938, computers. 1960, Internet. And in the early 2000s, it was the cloud computing. And in 2013, it's IoT. Now, what's so special about IoT? It actually encompasses internet, cloud computing, and a few other technologies that we are going to see in this tutorial. So, if you want to know or if you want to learn Internet of Things, you should have a fair amount of knowledge in cloud computing. Now, what is an IP address? An IP address is a unique address that is given to a computer to identify it in a distributed network. For example, you have 100 computers in a network. And how are you going to identify each computer? Obviously, you need to have a name, and that name is nothing but this IP address, which is unique across the world. So, in the internet, all the computers across the world had an IP address through which they were identified. Now, can you assign the IP address only to a computer? Not necessarily. You can assign an IP address to a printer, or you can assign it to a smartphone, or you can assign it to anything that could be connected across the network. Now, this forms the basic thought process of IoT, wherein you try to connect any device, anything onto the internet. So, for example, you can connect your microwave, you can connect your air conditioner, you can connect your refrigerator, or even you can connect your car to the internet. These days you could track your cars through a small app in your mobile phone. So all these things are possible because of these IP addresses. Now, the smartphone era, right? So you had computers, you had internet, you had cloud computing, and now it's the era of smartphones. People browse the internet through smartphones more than they do through the computers. Now, actually, smartphones revolutionized the way in which internet was used. In the early days, when people had to browse internet through the computers, not many of them had access to computers, which kind of restricted them to access the internet. But with the invention of smartphones, everybody, even in the remote part of the world, they have a smartphone through which they can tap into the internet. So the invention or the explosion of the usage of smartphones really created the platform for the Internet of Things to launch itself. Now, the computers connected together in isolation or the smartphones connected together in isolation is of not much use, because you can use your computer at home and you can use your smartphone when you are away. So how are you going to exchange and share data? How are you going to control devices through your computer or your smartphone? So you'll have to connect them together. And that is the next step towards understanding Internet of Things. So now you connect your smartphone with your computer, or you can connect your intelligent microwave with your computer or with your smartphone. So this predominantly forms the basic idea behind Internet of Things. Now you can connect anything through an IP onto the internet or onto the network. So this essentially is Internet of Things. So as we have discussed earlier, anything that can be assigned an IP could be considered as a thing, and these become smart because it acquires and transmits intelligence. And these devices or these things can be connected with one another. Now, why you should be interested in IoT? Because it's estimated that around 50 billion devices are going to be connected together by 2020. Now, 50 billion is a huge number. Or in another way, you can even think that anything and everything in your home would have an IP and would be connected to the network. And they are going to send huge amounts of data. And it's considered as the biggest technology wave after the internet. So folks, if you have missed out on the internet wave, make sure you write this on. And it makes our lives easier, and it can be used across all the industries, and more importantly, it can coexist with multiple of technologies. The most interesting thing about IoT is that it's not going to be used in isolation. It's going to coexist with artificial intelligence, blockchain, deep learning, machine learning, big data, analytics, and you name it, you can use that in Internet of Things. And it's going to create huge amounts of job. Now, if you really are considering to have a great career in the IT industry, it is very important that you understand Internet of Things. What are the building blocks of Internet of Things? Predominantly these 6 sensors that form the lowest part of the pyramid, and on top of it you have the actuators, and then you have the microcontrollers, protocols, application software and frameworks, and finally they are all connected and enabled through the internet or cloud. Now, what is the use of sensors? Sensors are going to take, or they are going to read information and send it back to the network. The actuators are going to act on the information that is pushed on to them. Microcontrollers have the assembly to control the sensors, actuators, and they have the ability to connect on to the network through the protocols. We are going to see all these things in detail through an example towards the end of this tutorial. Now, to make you understand, or to give you a context on how IoT works, let me give you an example. Suppose you have to measure the temperature in a particular region with a circumference of, let's say, 3 kilometers. How are you going to do that? You are going to install, let's say, 200 sensors at marked locations in that area. Now all these sensors should be interconnected. How are they interconnected? They are all connected through a network, and that network could be a local area network, or they could be a wide area network, or whatever it is. The idea is this network should be then connected on to a bigger network. It could be a cloud, or it could be directly through to the cloud, or through local internet onto the cloud. So whatever be the case, you need to connect these devices onto the internet. So the sensors absorb the data at various places. This particular temperature data is then passed on to the network, where it is stored in a database, and you can have application softwares written in any technology, be it Java, C# or Scala or Ruby or Python. These softwares can process the data, and this could be passed on to a big data stack for analytics, and you could push it through an artificial intelligence framework for prediction or gaining more insights and intelligence out of it. So you can do a lot of things with data. So this essentially, right, getting the data, gathering the data, transmitting them, processing them, and finally analyzing them forms the end-to-end of IoT. Now, there are different types of sensors, and all these sensors could be used in IoT. Some of the important sensors that are currently being used are the temperature sensor, pressure, proximity and displacement, acceleration, speed, mass, tilt, force, viscosity. So any of these sensors could be kind of plugged into a pre-assembled board like Arduino or BeagleBone or Raspberry Pi, and they can be connected on to the internet. Actuators. So what are actuators? Actuators are small mechanical devices like switch or relays that could act on something, that could trigger something into action. So what is the need for actuators in IoT? For example, Let's have a case where you want to switch on your air conditioner when the temperature crosses 35 degrees centigrade. So now what are you going to do? The sensor in your room is going to measure the temperature, and this sensor is connected onto a network which is going to process the temperature, and this network is again connected with an actuator which is actually going to switch on your AC through a relay. So now all these things are being controlled by your program or an app that you're going to have in your mobile phone or your smartphone. So there are different types of accelerators. They can trigger linear, oscillatory or rotatory motion, and they combined with sensors form the backbone of IoT. Now, as an analogy, you can consider a dam wherein the huge turbines are set into motion when water falls on them. So that rotatory motion is converted into mechanical energy. Now, folks, that essentially is it for today. So I want to leave you with a small case study where you want to switch on your microwave oven when you are 30 minutes away from your home driving back in your car. How are you going to do that? You can just think on your own. You can probably come up with a rough sketch and then try to connect all these building blocks together that could be used in this particular use case. So I am going to meet you with yet another interesting session on IoT. Till then, have a good time. Thank you.